Bismillahirrahmanirrahim. Hello students, how are you? You know this thing, why many students lose marks in physics? Not because it's hard, but because they misunderstand simple ideas like speed, velocity, acceleration, graph. Today I will make in this topic about the speed, about velocity and acceleration so clear, and we will also solve the past paper questions so that you can easily solve the IGCS questions confidently. So let's go here first of all about the speed. So look that here, if you check the speed, it means distance covered in unit time. How you will find it? Total distance over total time. In this way you can find the speed. Let's come to the unit. For distance the proper unit is meter. The SI unit for distance is meter. For time we will use second. For speed the unit will be meter per second. This is the standard unit. Other units can be used as well, kilometer per hour. It depends on the question. Okay, look at how you will solve the questions. First of all, you must know this equation. Average speed equal distance over time. For example, a car travels 50 meters in 2 seconds. Look, you have two things. 50 meter is a distance, time is 2 seconds. Simply write this equation, average speed equal distance over time. Now write the values in the equation. Distance moved is 50 meter and the time is 2 seconds. So your answer is 25 meter per second. So write your answer with the unit meter per second. So in this way you are able to find the speed. So let's see now what is the speed and velocity difference. Only there is one difference of direction. With the speed, no direction, but with the velocity you mention the direction. So basically in the velocity, if you say velocity is a combination of two things, speed and direction. Like here velocity is 25 meter per second. What is the direction? West. You know that we have four direction axes. Axis north, south, east, west, like that. Okay, here's the north, south, east, west. So if with the speed like you write 30 meter per second, you mention the direction also, basically it become velocity. So this is the difference. Velocity is a vector quantity because it has direction, and speed is scalar because it has no direction. So by the end of this lesson I hope you will understand about speed, velocity, acceleration, and also we'll discuss like distance time and the velocity time graph, and real questions we will also solve from the past papers. Like look that here, we say this cyclist is moving with the speed of 10 meter per second. This is the speed. Also we mention the direction to the right, so we are here describing the velocity. Okay, what is vector? This vector, not this vector. Okay, so basically vector means here quantities such as velocity are called vectors because they have two things, size and direction. Size, like I write here 25 meter per second, this is the size of the velocity, and direction, suppose I write here north. I hope this spelling is okay. Okay, now we come to the acceleration. Acceleration mean is the rate at which object increase its speed or velocity. For example, some object its initial speed is 20 meter per second and the final speed is 30 meter per second. Look, its speed change or not? When this change, it will take some time to change this time interval, for example 2 seconds. Okay, so in this way, this change in velocity with respect to time is called acceleration. How we calculate it? Change in velocity over time. Okay, we'll see different examples here. Mostly we write it v minus u. This v stand for final velocity and this u stand for initial velocity, v minus u over t. We will solve here different examples as well. Okay, for example here look, a drag car increases its velocity from 0 to 60 meter per second in 3 seconds. Look, from 0, this is the initial, to 60, this is the final. Time is 3. Just put the value v minus u. At the place of v you will write 60 minus 0 over 3. So your answer will be here 20 meter per second square. This is the unit for acceleration, meter per second square. Okay, look, same way, v minus u. V mean final velocity, u mean here initial, t means here time. So 60 minus 0 over 3, 60 over 3, 20 meter per second square. So de-acceleration means when its object slowing down, when it both apply the brake, we call it de-acceleration. Okay, now we come to the graph. If you see such graph, what is the meaning of this graph? For example, we have distance time graph. If you see a straight line going up, it means it shows a constant speed, this straight line, this one. But if you see the line is stationary, the line is flat like this, flat line means stationary. Okay, it means not moving. So at this point, for example, this time interval to this time, you can read along x-axis from maybe 9 to 30, or we cannot say it 9, 9.5, 9.7 to 12.2. We can say it's not moving, this object is not moving from the graph, and this straight line shows, okay, it's moving with constant speed. If you see the distance time graph, like look here, there are 3 parts of this graph. Okay, look, this straight line, these straight lines in the distance time graph means traveling at constant speed. It's moving, its speed is always, like if you find a speed at any time interval, you'll see it will be constant. How you find the speed? Okay, let's see also talk. If you find the slope of this graph, for at any point, for example on this line, choose any 2 points. Look, from 0 I choose first point, second point, for example I choose 6. Just draw these lines from 6. Look, choose any 2 point. Rise over run. What is the rise? 6. What is the run? Also 6. Rise mean along y-axis. This is y-axis. This is the rise. How much rise? 6 kilometer. How much run? 6 hours. So how you will find speed? If you find the slope of this line, slope will give you in the distance time graph. By calculating the slope, you can find the speed. So what is the rise here? Look, if I choose a different color, this is rise. Rise is 6. 6 minus 0 over run. What is the run? 6 minus 0. So your speed will be 6 over 6, and your answer will be 1 kilometer per hour. So if you have distance time graph, just find its slope, you can find the speed. So speed is equal to distance over time. So you need 2 things. Rise, this is rise. Choose any 2 points on the straight line. Okay, because speed will, on this line everywhere speed will be the same, constant means. So like on this point. So what is the rise here? Look, from where it starts, from 2 to 10. From 2 rise. Look, now rise start from where? What is the starting value? 2 and then 10. So 2 to 10 here. What is the rise? 8. What is the run? Run also check. Along x-axis 2 to 10. So 8. 8 over 8, 1 kilometer per hour. Okay, now we come to here different questions that we can solve it. First we will learn something about the velocity time graph. Okay, check that this is the velocity time graph. So what is the meaning of these lines? We must know. In the velocity time graph, the line is going up like that. It means constant acceleration. So for this line A to B, the acceleration is constant. But if you see B to C, the line is flat. It means constant velocity and acceleration will be 0. Okay, and also here, if the line is going down like that, it means steady deceleration. It means the speed is slowing down with respect to time. For example, look here at this point, for example, the speed is very near to 3, but with the passage of time it's going down, slowing down. Okay, then its speed becomes 0 at 8 seconds. Suppose somebody asks you, look now, at the 5 second maybe we can say the speed is 3, but at the 8 second if somebody asks you, speed becomes 0. So from 3 to 0, slowing down, steady deceleration. So how you can find the acceleration from velocity time graph? You have to choose that line where you want to find the acceleration, for example this line, then find its gradient or slope. Slope means rise over run. So look that this line starts from where? 0, and where it ends? 3. So what is the change along y-axis? 0 to 3. 3 minus 0, this is the change. What is the change along x-axis? This is x-axis. 2 minus 0. So 3 over 2. In this way you are able to find 1.5 meter per second square. So your answer is 3 over 2. And along this line, which is a flat line, if you see in the velocity time graph, acceleration is 0 because here the velocity is constant. Okay, so you will see different types of graph. You must know their meanings. So if you want to find the slope of the line at any point, you are able to find the acceleration. We also call it gradient word. Okay, keep in your mind please. But if you see the line is flat like that, acceleration 0 because no change in velocity. Here look the acceleration negative deceleration because it slowed down. Its speed was here 60, then it become how much? At the 50. Look now, at 30 seconds the speed is 60 meter per second, but when you come at 50 seconds the speed becomes 0, so it slow down. So the same way you will find its slope rise. Okay, so what is the rise here? What is its starting speed? 60. What is the final? Final speed is 0. In front of 50 read. Look, in front of 50 what is written? 0. Okay, in front of 30 seconds. Time interval is, time start from where? When it start deceleration? 30 to 50. This is the time interval, 30 to 50, 20 seconds. So you will find what is the rise here? Rise is 0 to 60. Okay, but it's negative. Final speed is 0 and initial speed is 60. So you will write 0 minus 60. Final minus initial over time interval. Change this change that it was 60, it becomes 0 in how much time? From 30 to 50. So what is the time interval? 30 to 50, your time interval will be 20. So 60 over 20, your answer will be minus 3 meter per second square. We will later on